Hi, in this video, I want to go over chapter 10 of Introductory Statistics in OpenStax. Chapter 10 has 4 sections and it's talking about the two population hypothesis test. So in chapter 9, we learn about the hypothesis test. We learn how to follow all the steps for a full hypothesis test. But in chapter 9, we talked about one population or one sample. Now, in this chapter, we want to talk about two populations. So since we have two populations, we have two samples as well. So if you remember in chapter 9, we talked about the two population mean. When we had a hypothesis test for population mean, we had two cases. First case was when the standard deviation of the population was known, and the other case was when the standard deviation of the population was unknown. We have these two cases here as well. In section 10.1, we are going to talk about the hypothesis test for two population mean with unknown standard deviations. But since we have two samples in this section chapter, we need to know if the samples are dependent or independent. What does it mean when samples are independent? It means that the sample who selected from the first population is not related to the sample that is chosen from the second population. But if each of the members in the first sample correspond to a member and are not in the second sample, we call them dependent. Being dependent or independent is one of the requirements for this chapter hypothesis test. So make sure that when you read the problem, understand that if the samples are dependent or independent. Right now, in 10.1 and 10.2, in this video, I'm going to go over the samples that are independent. And if the samples are dependent, we usually call them match pair samples as well. So let's look at an example. We want to determine whether the given sampling method is independent or dependent. First, it says a researcher wants to know whether the price of one night stay at the Holiday Inn Express is less than the price of one night stay at the Red Roof Inn. And the researcher randomly selects 8 towns where the location of the hotels is close to each other and determines the price of a one night stay. So we have two samples. One sample for Holiday Inn, one sample for Red Roof Inn. But the researcher selected 8 towns where the location of the hotels is close to each other. So what we can say, are these samples dependent or independent? Since both of the hotels are chosen from the same town, and also the location of these samples, these hotels are close to each other, we can say that they are dependent because they want to research about the price, and the price of the hotels usually depend on the town, the location of the hotel. So when they are close to each other and they are in the same town, so the price are similar to each other. So we can say that they are dependent. The second example says a researcher wants to know whether the state quarters have a mean weight that is different from the traditional quarter. The researcher randomly selects 18 state quarters and 16 traditional quarters and compares their weights. So in this case, the first sample are 18 state quarters, the second sample is 16 traditional quarters, and they are completely independent from each other. So these two samples are independent. Okay, after learning about the dependent or independent sample, now we want to know what type of test are we going to use. Same as chapter 9, when we talked about the hypothesis test for population mean, when the standard deviation was unknown, we use t-test. So we do the same here. When the standard deviations are unknown, we use t-tests. But this time we have a two-sample t-test. When we have two samples, that means we have two population. So we have two mu and two sigma. We have mu1 and mu2 that are population means, sigma 1 and sigma 2, which are population's standard deviation. And in this case, they are unknown. That means we don't have any information about the population standard deviation. So to start any hypothesis test, we need to check the requirement. So what are the requirements? First, the samples must be random. Second, the samples must be independent. And the third requirement that says the population must be normally distributed, or not, each of those samples must be greater than 30. So make sure every time you read the problem and check the requirement first. After you check the requirement and the problem satisfies all these requirements, we are going to use the standardized test statistic T, which it has this formula. That is the formula, and the bottom of the fraction is called the standard error. So the standard error, so if you remember in last section, and we had the formula that we had for the t-test was t equal x bar minus mu over s over the square root of n. And this was the standard error because we had only one sample. We had x bar, which was the sample mean, mu, which was the population. This time, since we have two population and two samples, so instead of one x bar, we have x bar 1 minus x bar 2. Instead of 1 mu, we have mu 1 minus mu 2. And the standard error in this case, it's a little different. And the formula for this one is this formula. And this formula requires a pooled estimate of the standard deviation. Sigma hat is called the pooled estimate of the population standard deviation. And why do we need to calculate this one? And how do we need to calculate this one? It depends that the variances of the populations are equal or not equal. So in this case, we don't have any information about the population standard deviation. But we may assume that the variances are equal or not equal. So usually in the problem, they tell us if the variances are equal or not equal. If variances of the populations are equal, we need a pooled estimate of the standard deviation, which is sigma hat, and that comes from this formula. And then after finding this, we multiply that by this square root. And for any time we are using t-test, we are finding the critical value from the t-table, and the t-table needs a degrees of freedom. And the degrees of freedom in this case is coming from this formula. This time the degrees of freedom is n1 plus n2 minus 2. N1 means the first sample size, n2 means the second sample size. Add them together and then minus 2. And after finding them, we calculate the test statistic and just follow the other steps that we had it before as well. But if the problem in the problem the variances are not equal, the standard error that we use for the denominator of that fraction is just this one. We don't need the pool estimate of the variances. And again, since we need the degrees of freedom to find the critical values from the t-table, in this case, the degrees of freedom is the smaller number between n1 minus 1 and n2 minus 1. We have two samples. We subtract one from each of those sample sizes, and in each of them that is a smaller number, we use that number as a degrees of freedom. So I put all of the steps here in this table for you. So as you see, the steps that we follow, they are completely similar to the steps that we had in chapter 9. So if you completely learn, everything in chapter 9, you don't have any problem, just the formulas are different. So first, as the first step, we need to check the requirement. The samples must be random, the samples must be independent, and the population must be normally distributed, or each of the sample sizes must be more than 30. After checking the requirement, we need to state the claim and write the null and alternative hypotheses. And remember, this time, since we have two populations, when we are writing the null and alternative hypothesis, we will have two mu. And to write the null and alternative hypothesis, we should have mu1 and mu2. And based on the claim, mu1 is less than mu2 or more than mu2 or equal to mu2. And don't forget that similar to chapter 9, equal sign always goes for the null, and alternative do not include any equal sign. Okay, then after writing the null and alternative hypothesis, we need to find the degrees of freedom because we are going to use t-test. And if the population variances are equal, we use this formula. If they are not equal, we use either of these that are smaller. Then we need to find the critical value and the rejection region from the t-table because we are following the rejection region method. After finding the rejection region, we need to find the test statistic. Again, based on if the variances are equal or not equal, we need to use one of these formulas. And after finding the test statistic, we need to check if the t falls in the rejection region or not. If it falls in the rejection region, we reject the null hypothesis. If it doesn't, we fail to reject. So that's all the steps that we follow. And why I usually do the rejection region method, because rejection region method is the best method if I'm working on the problem manually. If you want to use calculators or use TI-83 or 84 calculators or online calculator, you usually need the p-value method because the p-value can be calculated only by those types of calculator. But if you want to work on the problem manually, you don't have any of those calculators or you don't want to use any of those, the best method is the rejection region method. And these are the formulas that we can follow for if we are using the TI-83 or 84. So let's look at this first example. It says the result of a state mathematics test for random samples of students taught by two different teachers at the same school are shown in this table. Can you conclude that there is a difference in the mean mathematics test scores for the students of the two teachers? When he says there is a difference between the mean score, that means the mean scores are not equal to each other. They are different from each other. Now, and it says that the alpha is 10%. Alpha, it's a significance level. Assume that the populations are normally distributed and the population variances are not equal. So the problem told me that the population variances are not equal, which it means that you are going to use this formula because they are not equal. And that is the formula for finding the degrees of freedom, since the variances are not equal. Okay. So first of all, the first step is always checking the requirement. When we check the requirement, are samples random? Yes. Are samples independent from each other? So the samples are independent because they are two samples from two different teachers. So that should be completely different. Students from two different teachers. So we know that the samples are also different. And we need to check if populations are normally distributed or sample sizes are more than 30. As you see, the sample sizes are not more than 30, but it mentioned here that assume that the populations are normally distributed. Since it mentioned that this one, so we don't need to check the sample size. So yes, this problem met all the requirements. Now we need to write the null and alternative hypothesis. To write the null and alternative hypothesis, you know that we have two populations. That means we have two population means, mu1 and mu2. Since the problem says that there is a difference, the claim says that there is a difference in the mean, that means mu1 and mu2 must not be equal. So mu1 not equal always goes for the alternative, and that's the claim. And if the alternative is not equal to, it means that the null must be equal to. Okay, now I am done with the null and alternative hypothesis. So the next step is finding the critical values and the rejection region. Since sigma or the population standard deviations are unknown, we are going to use t-test. Okay, if you're using t-test, you need a degrees of freedom. So how do we find the degrees of freedom? Go back to the table. Since the population variances are not equal, degrees of freedom is the smaller number of n1 minus 1 or n2 minus 1. n1 minus 1, the first sample size is 8, so 8 minus 1 is 7. 18 minus 1, which is 17. Which one is smaller? This one. So this number is my degrees of freedom. So the degrees of freedom is 7, and I know that the alpha is also 10%. Now we look at the t-table to find the critical value. So if we look at the t-table, degrees of freedom is 7, and alpha is 10%, but the question is, this 10% is for one tail or two tails? Let's go back to the alternative hypothesis. Alternative hypothesis has not equal sign. Not equal sign means I have a two-tail test. And two-tail test, it means that 10.10 or 10% is for two-tail. So I just look at the two-tail and look for 10%. Now the number that I find is 1.895. But you know, in every t-test, when you have a two-tail test, you always have two critical values. One positive critical value and one negative critical value. That means we have positive 1.895 here and negative 1.895 here. And these areas, on the two tails, are the rejection regions. So the rejection region are the numbers, any t-value that's less than negative 1.895 and any t-value that's more than positive 1.895. And after finding the rejection region, now it's time to calculate the test statistic. So we know the formula. When variances are not equal, we're going to use this formula. And in this formula, we replace number for x1, x2, s1, s2, n1, and n2. X bar means the first sample mean. X2 means the second sample mean. Mu1 minus mu2 is always 0. Why? Because if you go back to the problem, in the null hypothesis, you always assume in the null hypothesis that the mu1 is equal to mu2, which it means if you subtract both sides, subtract mu2 from both sides, mu1 minus mu2 is always 0. If they are equal, that means the difference is 0. So remember, so in all of this problem, mu1 minus mu2 is always 0. But we have numbers for x1 and x2. We need to subtract them. We have numbers for the standard deviation of each samples, the sample sizes. We put them in the formula and find the test statistic. After finding the test statistic, now it's time to check if this number falls in the rejection region or not. The rejection region tells me that any number that's more than 1.895 or less than negative 1.895. Is this number in the rejection region? No. If it's not in the rejection region, that means we fail to reject the null. Okay? And when you fail to reject the null, so if you remember the null and alternative hypotheses, or the null and alternative hypothesis, I put them here again. If you remember the null and alternative hypotheses, and if you fail to reject the null, that means you reject the alternative. An alternative is the claim. Anytime the claim is on the alternative, I'm going to use the word support. But I'm rejecting. I cannot support it. So it means that there is not enough evidence at 10% level of significance to support the claim that the mean mathematics test score for the students of the two teachers are different. Let's look at the next example. Feel free to pause the video, work on the problem, and then check your work after you're done with me. So in the second example, it says an automobile manufacturer claims that the mean driving cost per mile of its sedans is less than that of its leading competitor. You conducted the study using 30 randomly selected sedans from the manufacturer and 32 from the leading competitor. The results are shown in this table. If alpha is 5%, if the level of significance is 5%, can you support the manufacturer's claim? And it says assume that the population variances are equal. Okay. As a first step, I always check the requirement. Don't forget the steps on the table. First, check the requirement. Are samples random? Yes. Are samples independent? Yes, because they're coming from two different manufacturers. Are populations normally distributed? We don't know, but our sample size is more than 30? Yes. Okay. We check the requirement. The problem met all the requirements. Now we can move on to the next step, which is writing the null and alternative hypothesis. So to write the null and alternative hypothesis, remember, since we have two populations, we have two mu. So we have mu1 and mu2. We always have mu1, mu2. We have to find the claim. The claim says that the mean driving cost is less than the competitor. Okay, if the manufacturer is the first sample and the competitors are the second sample, that means mu1 is less than mu2. Where do we put mu1 less than mu2? And the alternative, because alternative do not include equal sign. And that's a claim. And if the alternative is less than, it means that the null is greater than or equal to. After writing the null and alternative hypothesis, now, since I'm following the rejection region method, I need to find the critical values. Since we have less than for the alternative, that means we have a left tail test. It means that You have one critical value here, and the rejection region is area on the left. That's the rejection. Now I need to find the critical value, this value. To find this value, I need to use the t-table. But to use the t-table, I need to know the degrees of freedom. Since population variances are equal, I'm going to use the formula for that, which is n1 plus n2 minus 2. Since variances are equal, I'm going to use this formula. And then after that, after finding the rejection region, we use this formula to find the test statistic as well. So if I go back to this problem, n1, so the degrees of freedom is n1 plus n2 minus 2, which is 30 plus 32 minus 2. And the answer is 60. So the degrees of freedom is 60. And I know I have a left tail test. That means this area is area on the left. So 0.05, it's one tail, for one tail. So now I look at the t-table, and after looking at the t-table, one tail 0.05 and 60 for the degrees of freedom, and the answer is 1.671. This is my critical value. But if you remember, in chapter 9, I told you, since the t-table always gives us same answer for one tail test, and there is no difference between the right tail or left tail tests, if we find the answer for one tail, but if it's left tail, we keep the number negative. If it's right tail, we keep it positive. Since in this test, we have a right tail test, we have a left tail test, that means my critical value must be negative. And the answer here gives me 1.671, but negative 1.671. So the critical value is negative 1.671. And the rejection region, it's all the numbers that are on the left side of this number, or all of the t-values that are less than negative 1.671. After finding the rejection region, now it's time to calculate the test statistic. Okay, find the denominator separately and then put it in the formula, and now you see that the answer is negative 1.930. And don't forget that the mu1 minus mu2 is always 0. After finding the answer, we need to check if it's in the rejection region or not. So for the rejection region, you said negative 1.671. You said any number that is less than this number, it's in the rejection region. And the answer is negative 1.93. And I feel that is inside of the rejection region, because negative 1.9 is less than negative 1.6. So it means that this number is in the rejection region. If it's in the rejection region, you need to reject the null hypothesis. And if you reject the null hypothesis, let's see, where's the claim? The claim is on the alternative. If you reject the null, that means you have enough evidence to support the alternative. And since the claim is on the alternative, you are going to use the word support. And you are supporting the alternative because you're rejecting the null. So there is enough evidence to support the claim that the mean deriving cost per mile of its sedans is less than of its competitor. So something that's important that you remember, we are following same steps for hypothesis tests. Chapter 9 and Chapter 9 are following same steps. If you're using rejection region method, you have same steps for one sample and two samples. If you're using p-value method, again, you have same samples from one sample and two samples. The only thing that's different is the formula for the test statistic. And if we have to find the degrees of freedom, that is different as well. In section 10.2, we are going to talk about the hypothesis test for two population mean, but this time with known standard deviations. This time we have information about the population standard deviation. If you remember, in this case, in chapter 9, we were using z-test. So we do the same. We are going to use z-test again because the sigma are noun. Anytime sigma are noun, we use z-test. So all the steps for the rejection region method is here. And that's a formula that we use for the z-test. So we find the critical value from the z-table. For z-table, we don't need the degrees of freedom. We just need alpha and the area under the curve. Okay, so let's start working on a problem. The first example says a credit card watchdog group claims that there is a difference in the mean credit card debts of people in Oklahoma and North Carolina. So that's a claim. There is a difference. There is a difference in the mean. That means the means are not the same. That means mu1 and mu2 are not equal to each other. The result of a random survey of 250 people from each state are shown at the left, or on this table. The two samples are independent, okay? Assume that the sigma 1 is $960, that's the first population standard deviation, and the sigma 2 is 845, that's the second population standard deviation. Now the question is, do the results support the claim if alpha is 5%? Okay, so if I look at the steps, first step tells me that check the requirement, same requirement as the previous section. Samples must be random, independent, and the population must be normally distributed. So samples are random, samples are independent, and the populations are, doesn't mention if the population are normally distributed, but the sample sizes are more than 30. So everything is fine. Second step, we need to find a claim and write the null and alternative. Okay, the claim says that there is a difference. Okay, when there is a difference, that means the mu1 and mu2 are not the same. And we always put the not equal sign for the alternative. So the claim is in the alternative. That means the null must be equal sign. After writing the null and alternative hypothesis, we need to use z-table to find the critical values and the rejection region. Okay. If you want to use the z-table, first you need to know that if you have a two-tail test or one-tail test. If it's a left tail, right tail, two-tail. The alternative hypothesis tells me that I have a two-tail test. Two-tail test means I have two critical values. And the alpha, which is 5%, it's the total area on both tails. That means half of the alpha is on the left, the other half is on the right. And half of the 5% is 2.5% or 0.025. Now, by looking at the body of the z-table and look for this number, I can find the z-value. Okay, let's look at the z-table. I'm trying to find this area, 0.025. And 0.025 is here. After finding that number, I know that the z-value that corresponds to this area is negative 1.96. But I know that I have two critical values. That means one of them is negative 1.96, so the other one is positive 1.96. And the rejection regions are these shaded area. That means any number that's less than negative 1.96 and any number that's more than positive 1.96. After finding the critical value, now it's time to use the formula and calculate the test statistic. Again, don't forget that the mu1 minus mu2 is always 0 because we always assume that mu1 is equal to mu2. I found the test statistic is 1.85. Now it's time to check if 1.585 is in the rejection region. The rejection region tells me more than 1.96 and less than negative 1.96. You can see it in the picture. But 1.85 is not in that rejection region. So if it's not in the rejection region, we fail to reject the null. And if you fail to reject the null, that means you reject the alternative. If you reject the alternative, that means you're rejecting the claim. That means you cannot support the claim. So what do we say now? We say there is not enough evidence to support the claim. So there is not enough evidence at 5% level of significance to support the claim that there is a difference in the mean credit forecast of the people in those two states. So let's look at another example. Next example, it says a real estate agency says that the mean home sale price in Casper, Wyoming is the same as the Cheyenne, Wyoming. So the claim, I'm going to underline the claim. The claim says that the mean home sale price is the same. So if this is mu1, if this is mu1, and that's mu2, mu1 must be equal to mu2 based on the claim. The mean home sale price for 35 randomly chosen homes in Casper is, let me just write the information here for you. So the mean home sale price for 35 randomly chooses, so the first sample is 35. The mean is 349,237. And it says, assume that the population standard deviation is this. So population standard deviation means sigma. And sigma 1 is 139,789. And it says the mean home sale price for 41 randomly chosen, that's the second sample. The mean is export 2, 435,244. And assume that the population standard deviation, or sigma 2, is equal to 150,865. I know that the alpha is 5%. And then the question is there enough evidence to reject the claim? If you read the question, first of all, you need to make sure that the sigmas are noun or unnoun, because we know if sigma are noun, we are going to use z-test. If they are unnoun, we are going to use t-test. In this case, the sigma are given to us. So that means the sigmas are noun. So that means I'm going to use z-test. Okay, so I need to check the requirement first before I start the problem. So these are the steps that I'm going to follow for the z-test. So first, I need to check the requirement. Are samples random, are independent, or the population is normally distributed? The samples are random, yes. The samples are independent, yes, because they are coming from two different cities. And our population is normally distributed? I don't know, but the sample sizes are more than 30. Okay. I check the requirement. Now, step 2, I need to write this null and alternative hypothesis based on the claim. So to write the null and alternative hypothesis, we look at the claim. The claim says that the mean home sale price in the first sample and the second one is the same. That means mu1 is equal to mu2. And you know we always put the equal sign for the null hypothesis. And this is my claim. If the null hypothesis is equal to, that means the alternative is not equal to. And this not equal sign tells me that I have a two-tailed test. Now it's time to find the critical values and the rejection. So when you have a two-tailed test, that means you have two critical values. And the shaded area are on the two tails. This shaded area, it's the alpha. But you know that half of them is on the right, the other half is on the left. If alpha is 0.05, half of the alpha is on the right, the other half is on the left. Now, I'm going to look at the z-table and look for this area to find the corresponding z-value. I did it in a previous example and I found negative 1.96 and positive 1.96. So it means that the rejection region, the critical values are negative and positive 1.96, but the rejection regions are this shaded area. That means any z-value that's less than negative 1.96 and any z-value that's more than positive 1.96. I keep this rejection region because at the end, after finding the test statistic, if my z-value falls in the any of these regions, I need to reject the null. Now, after finding them, I need to use find a standardized test statistic, and that's a formula I'm going to use. Okay. So write the formula. I have x bar 1. So I don't have enough space to write both of the formulas on. Just I replace a number here. X bar 1 minus x bar 2 minus mu1 minus mu2, which is always 0, because we assume that mu1 is equal to mu2. And then at the bottom of the fraction, we have sigma 1 square divided by n1 plus sigma 2 square under the square root, sigma 2 square, which is 158.65 square divided by n2. I put these whole things in the calculator and find the z. And remember that since we have a plus sign here, we cannot bring anything out of this radical out, okay? So don't cancel the radicals and the squares because of this positive sign. You can do that. So you need to calculate everything inside the radical, take the root, subtract the numbers on the top, and then divide by each other, and the final answer is negative 2.58. After finding the z-value, now it's time to check if it falls in the rejection region. Negative 2.58 is somewhere over here because it's less than negative 1.96. And it means that it's in the rejection region. If it's in the rejection region, that means you need to reject the null. So I'm going to reject the null. But the null is the claim. That means you're rejecting the claim. And when the claim is on the null, you need to use the word reject. And you can say there is enough evidence to reject the claim. So we reject the claim, we reject the null. And since the null is the claim, we say there is enough evidence to reject the claim that the mean home sale price in Casper and Cheyenne are the same. Okay, make sure to have a complete sentence. Okay. And the last example in this video, it says, a personnel director in a particular state claims that the mean annual income is greater in one of the state's counties, in county A than in county B. Okay, that's a claim. So if you want to write the null and alternative hypothesis based on the claim, you can also mention, instead of mu1 and mu2, you can put mu A and mu B. I mean, mean in county A, mean in county B. Or you can still say mean mu1 and mu2. So the claim says that the mean in county A is greater than. Greater than means we need to put it on the alternative. And that's the claim. If the alternative is greater than, that means the null is less than or equal to. Okay, I usually like to write my null and alternative hypothesis when I'm reading the claim. Now read the rest of the problem. It says in county A random sample of 17, so N1 is 17, the first sample, has the mean annual income of 41,500 and a standard deviation of 8,300. This standard deviation is the standard deviation of the sample, because this sentence is talking about the sample. And it's when it says the sample has a mean and a standard deviation, that means this standard deviation is for the sample. So S1 is 8,300. In county B, a random sample, the sample size is 8. X2, X bar, the mean is 38,500. And the standard deviation, again, is the standard deviation of the sample. Alpha is 5%. Can we reject the claim? And it says, assume that the populations are normally distributed and the population variances are not equal. That's important as well. So you know that in this case, we don't have any information about the population standard deviation. These two standard deviations are the sample's standard deviation. Since there is no information about the population standard deviation, that means the sigma are unknown. And if the sigma are unknown, I'm going to use t-test. So following this step, need to check the requirement, write the null and alternative hypothesis, then find the degrees of freedom, because I need the degrees of freedom to look at the t-table and find the critical values. To check the requirement, I need to make sure that the samples are random. They are, it mentioned here. Sample must be independent. They are independent because they are coming from two different counties. And the population must be normally distributed, and they are. Okay? Everything is fine. We met all, this problem met all the requirements. We need to write the null and alternative hypothesis, and we did it here. Then we need to find the degrees of freedom to look at the t-table. Since it says variances are not equal means this case. So for finding the degrees of freedom, I need the smaller number between n1 minus 1 and n2 minus 1. n1 is 17. Minus 1 gives me 16. n2 is 8. Minus 1 is 7. Which one is smaller? 7. So the degrees of freedom is 7. And I know that the alpha is 0.05. And what type of test is this one? Is it the one-tail test or two-tail test? Yes, that is a one-tail test because we have greater than here. Greater than means If this is the critical value, this is my rejection region. That's a right tail test. Okay, so I have a one tail test. Alpha is 5%, degrees of freedom is 7. I'm going to look at the t-table. If one tail is 5% and if degrees of freedom is 7, my answer is 1.895. So my critical value is 1.895. Do I have to keep it positive or negative? We keep it positive, yes, because it's a right tail test. If it was left tail test, I keep that in negative form. After finding the critical value, I know that the rejection region is the shaded area, and the shaded area means any t-value that is greater than this number because it's on the right side. Now, after finding the rejection region, next step is find a standardized test. Since variances are not equal, I'm going to use this formula. Okay? So let's write the formula. And then replace numbers. Export 1, which is 41,500, minus export 2, which is 38,500. And then minus, I know the mu1 minus mu2 is always 0. I need the square root of S1 squared. That means 8,300 S squared divided by N1, which is 17. S2 is 5,100 S squared divided by 8. Put this one in calculator and then find the answer. And the final answer here is 1.11. After finding the test statistic, now we want to make our decision. For decision, we need to check if this value is in the rejection region or not. Rejection region tells me the number that should be more than 1.8, but this number is not more than 1.8. So it's not in the rejection region. If it's not in the rejection region, we fail to reject the null. If you fail to reject the null, that means you reject the alternative. If you reject the alternative, you're kind of rejecting the claim. But when the claim is on the alternative, I'm supposed to support it, but I'm rejecting now. So what should I have to say? I say there is not enough evidence at 5% level of significance to support the claim that the mean annual income in country A is greater than country B. That's the final answer. So this is how we work on the problem manually. We can also work on them through the online calculators. You can use TI-83 or 84 calculator, or you can use online calculators. So if you open online calculators to go down, you will see that we have number 17 and 18 are the two independent sample with data or two independent sample with a statistic. We have to use one of these two. If we have all of the data from the samples, I need to use number 17. But if I only have some information about each samples, like the mean and the standard deviation, that means I only have statistics. So I'm going to go and use number 18. Open calculator number 18, and it's asking me to, for each of the samples, type in the sample sizes. What's the first sample size? It's 17. It was 17. The second sample size was 8. What was the first sample mean? 41,500. And the second sample mean, that was 38,500. The first sample standard deviation, 8,300. And the second one, that's 5,100. Now I need to choose the claim. The claim says greater than. So since the claim says greater than, I'm going to choose this notation. And it's asking me to, what's the confidence level? You know that in hypothesis test, we always use the significance level, which is 1 minus the confidence level. That's right. So if alpha is 5%, that means the confidence level is 0.95. So make sure to type 0.95. And then press calculate. And it gives you the t-value, which is 1.11. And you see that we also found 1.11 here. That's the same. And it's also giving you p-value. If when you're working on the homework problem, if in any question asking you to what's the p-value, you must use the calculator, because there is no way that we can find the p-value, especially when we are using the t-test by hand. So, and that's the p-value. And you know, whenever we have p-value, to make our decision, we compare the p-value with alpha. Alpha was 5%. We know that if p-value is less than or equal to alpha, we reject. If it's more than, we fail to reject. And in this example, the p-value is more than 5%. That means you fail to reject the null. And we also, in rejection region method, we also decided to fail. We do not reject the null. We fail to reject the null. So if you want to use a calculator, make sure to use number 18 for sample means. So these two are for sample mean, but if you have data values, you need to use number 17 and type in all of the datas and then find the t-value and the p-value here. But we don't have any online calculator for z-table. So make sure if you have a problem for two sample with non-standard deviation, which requires you to use the z-table, do it by hand. There is no way that we don't have any online calculator. You only have a chance to use the TI-83 or 84 calculators, or use it manual, use the table and work on the problem manual.